Hey, so you ever kind of looked back in history and wondered, so we've started in the 1940s with electronic components and vacuum tubes, and now we're at this age where computers can spout poetry and write working code? How did we get here? Technical abstraction layers. Let's talk about it. Oh yeah, so imagine this. I'm in the Red Hat engineering office in Westford, Massachusetts. We're having lunch in the cafeteria, sitting at a table with a bunch of other engineers that work on Linux, my friends. And we look over and there's a doormat, and I realize that doormat, that's not just like a little pattern. It's actually ones and zeros. It must say something. It must be in binary. So all of us are like gathered around the table and we're like trying to figure out, oh, what does it say? What does it say? It said welcome. But, it should be obvious. You look at a doormat and it says welcome, right? But it took a table of engineers to think through, oh, what could it say? What could it say? Let's decode it. That's effort. That's time. You just want somebody to feel welcome. If they have to sit there with like a calculator and a textbook to figure out what you're saying, that's not efficient. So why is Mo telling this crazy story? Okay, so computers speak this language. It happens to be ones and zeros. We call it binary or machine language. So computers speak language A, you speak language B. You are a human. How do these two communicate? The computer's going to have to learn your language, or you're going to have to learn the computer's language. Over time, we've developed abstraction layers to get these two together so that humans can benefit from technology. So we've had humans in the beginning learning machine code, ones and zeros. Kind of sucked. So then we had computers able to do assembly at another layer, and okay, a little bit better than ones and zeros. Then we had compiled software programming languages like C or Fortran or Pascal, and the computers kind of came over here. And then we had humans learning even more abstract things all the way to generative AI. So we've had, with GenAI, we had these two different languages. Now the computers can understand human language. So the way that I see generative AI providing this new abstraction layer, it opens up the landscape for anybody with a diverse set of backgrounds and deep expertise to be able to participate in the building of open source software. And I think when you have a diverse group of people who have expertise to lend to everyone else, who can collaborate together and share and build on each other's work, you're going to have better technology that serves humans' needs. And that's the whole point, isn't it? The point of technology, yes, it's very cool. Yes, we like to play with it. But the point is to solve people's problems, to make life a little easier. And I think when we have this flood of expertise into open source, it's going to enable so much of that. So your takeaway, what can you build? What's a tedious, repetitive thing you have to do, like writing ones and zeros, something equivalent to that? Can you use generative AI to develop a little script or a little tool to take that tedium away so that you can use your expertise to go even further? Think of that abstraction layer going up and up and up. Let's get you up here so you're doing amazing, amazing things and having the biggest impact you can have.